Hi, welcome to this lesson on expansion of algebraic linear expressions. Here are the learning objectives of this lesson. In this lesson, you will learn to expand the product of a number and an algebraic linear expression by using the algebraic disk, the area model, and the multiplication frame. You will also learn to state the distributive law of multiplication over addition and recognize equivalent expressions in the expansion. Let us begin with the mathematical vocabulary commonly used in this topic. What is an algebraic expression? Let's look at these four examples here. These are algebraic expressions. You notice that all these examples do not include an equal sign. Each example involves a letter such as x in x plus 2, y in 1 minus 2y, p in 3p, a and b in half a plus 5b. Each example is also made up of numbers such as 2 in x plus 2, 1 and 2 in 1 minus 2y, 3 in 3p, half and 5 in half a plus 5b. In the example x plus 2, you see that the letter x and the number 2 are joined by addition. In the example 1 minus 2y, the number 1 and the term 2y are joined by subtraction. And in the term 2y, the number 2 and y are joined by multiplication. What is then an algebraic linear expression? It is where the power of each term containing a variable is 1. Let us look at the following three examples. These are algebraic linear expressions in one variable. The first example is an algebraic linear expression in x. The second example is an algebraic linear expression in y. The third example is an algebraic linear expression in p. Now, the next two examples are not algebraic linear expressions. Why is that so? Let's look at the first example. Now, the first example contains three terms: x squared, 3x, and 2. Look at the terms x squared and 3x. The power of x squared is 2, and the power of x in 3x is 1. The power of these two terms are not all 1. In the second example, 3p plus p cubed minus 1, the first term 3p, the power of p is 1. In the second term p cubed, the power of p is 3. The power of each term is not 1. So therefore, 3p plus p cubed minus 1 is not an algebraic linear expression. Can we have algebraic linear expressions in two variables? The answer is yes. So now we will look at two examples. The first example, half a plus 5b, is an algebraic linear expression in a and b because the power of a is 1 and the power of b is 1. The power of each term containing the variable is 1. Now, can you try to explain why k plus 3m minus 4 is an algebraic linear expression in two variables, k and m? Now, let's take a look at the word expand. What does this word mean? In science, when we say that a metal ball is heated, its volume increases. We say that the ball expands. But in maths, what does it mean? What do we expand? Let us now take a look. Consider the example 2 bracket x plus 3. What this expression means is 2 times the bracket x plus 3. So this expression is made up of a number and an algebraic linear expression. And we see that it is the product of the number 2 and an algebraic linear expression. So to expand a product of a number and an algebraic linear expression, it means that we need to multiply out the product into a sum of terms. What does this mean? We will be looking at this after this slide. So what does the word expansion now means? It refers to the process of multiplying out the product into a sum of terms. Okay, we are now ready to look at how to expand a product of a number and an algebraic linear expression. Consider the same example 2 times the algebraic linear expression x plus 3. I'm going to show you how we can do the expansion by using algebra disk. Algebra disks are manipulatives that looks like this in the picture. Let's look at the disk containing x on one side. On the reverse side, it is negative x, because negative x is the opposite of x. That's why it is written on the opposite side of x. And we have done this with the number 1. And on the opposite side, it is negative 1. Now how do we use algebra disk to expand 2 times x plus 3? Let us now take a look at the video. It means 2 groups of x plus 3. Now let me show you one group of x plus 3. This is x plus 3. So this is one group of x plus 3. And I have 2 groups. So you see that altogether there are 2x and 6. So the answer is 2x plus 6. Now, we can look at the product of 2 and x plus 3 in another way. Let's consider 2 and x plus 3 as the dimensions of a rectangle. So we have a rectangle with sides x plus 3 and 2. What does the product of 2 and x plus 3 refer to in the rectangle? Yes, it refers to the area of the rectangle. We can also look at the area of this rectangle in another way. Let's take a look. We can look at the rectangle in a different way. We can see it as being made up of 2 smaller rectangles. One is with sides 2 and x, and the other one is with sides 2 and 3. How do we find the area of these 2 rectangles? Yes, the areas of rectangles are 2x plus 6. So, what can we now say about the expression 2 times x plus 3 and the expression 2x plus 6? Because the areas are the same, so therefore we can say that 2 times x plus 3 is 2x plus 6. Now, some of you may find drawing a rectangle very troublesome. So let me now show you a shortcut to do that. Instead of drawing a rectangle, we can draw what we call multiplication frame. It looks like this. Right? So this portion here resembles the rectangle with sides 2 and x plus 3. So now, what does 2 times x give you? It gives you 2x. So we write 2x in this cell here. And what do we write in this cell? It's 2 times plus 3, and that gives you plus 6. So therefore, 2 times x plus 3 is 2x plus 6. Let us now look at another example. Can you expand negative 3 times x plus 4? I give you some time to try out this question. Okay, so what are you going to feel? Okay, so what do you feel in this cell here? That's right, negative 3x. How about this cell? That's right, it's negative 12. So, what is negative 3 times x plus 4? It is negative 3x minus 12. It's now time for practice. I'd like you to attempt the following two questions. Expand using the multiplication frame 1, 2 times y plus 3z. And the second question, negative 5 times x minus 2. You may pause the video to attempt these two questions. You will be able to check your answers at the end of this video. Let us move on. You have so far learned to expand a product of a number and an algebraic linear expression. What if you are asked to expand this, the product of a and x plus b? What would your answer be? Let's draw out this multiplication frame and fill in the two blanks. Did you get these two answers? AX and plus AB. So now we know A times x plus b gives AX plus AB. When we multiply A to the sum of x and b, we distribute A to x first and then to b. Then we sum up the two products AX and AB. This interesting property is called the distributive law of multiplication over addition. Now, let's take a look at this equation. In the previous section, we have learned that 2 times x plus 3 gives 2x plus 6. What if the letter x on the left-hand side is replaced by a value, and the letter x on the right-hand side is also replaced by the same value? What can we say about the value on the left-hand side and the value on the right-hand side? Let us now take a look. Suppose we replace x by 0. Then the left-hand side expression will give us 2 times 0 plus 3, which gives us the value 6. And the right-hand side expression gives us 2 times 0 plus 6, which also gives 6. The value obtained on the left-hand side and the value obtained on the right-hand side are equal. Let us try replacing x by another value. This time, let's try x equals to 1. Now, I'd like you to work out the value on the left-hand side and the value on the right-hand side. What do you get? You may pause the video to work out the values. Did you get the value 8 on the left-hand side and also 8 on the right-hand side? So again, the value obtained on the left-hand side and the value obtained on the right-hand side are equal. In fact, if you replace x with any real numbers, the value obtained on the left-hand side will equal to the value obtained on the right-hand side. So we call 2 times x plus 3 equals to 2x plus 6 an identity. What is an identity? It is an equation that is always true when the variable is replaced by any value. Can you now write out another identity? Give it a try. In the identity, 2 times x plus 3 equals to 2x plus 6. We observe that the expression on the left-hand side is the product of 2 and x plus 3. The expression on the right-hand side is 2x plus 6. These two expressions look very different, but they produce the same value when x is replaced by any number. So, we say that the product of 2 and x plus 3 and the sum 2x plus 6 are equivalent expressions. What did I cover in this lesson? You learned to expand 2 times x plus 3 using algebra disk. And you also learn to expand using the area model. And you can see that the two methods are similar. This portion here showing 2 red discs of x correspond to 2x, which is the area of this smaller rectangle. And this portion here showing 6 discs of 1 correspond to the area of this larger rectangle. You have also learned to expand using the multiplication frame. Now, if you were to compare the area model method and the multiplication frame method, you'll notice some similarities again. This portion here is like the rectangle here. The multiplication frame method might be easier for you. You don't have to draw a rectangle, but you just need to draw a frame that allows you to work out the expansion. So we see that 2 times x plus 3 equals to 2x plus 6. And we call this an identity. The left-hand side of the identity is the product of a number and an algebraic linear expression. And the right-hand side is the sum of terms. So when we expand the product of a number and an algebraic linear expression, what it means is to multiply out the product into a sum of terms. And we have also noticed that the expression on the left-hand side and the expression on the right-hand side are equivalent. It's now time for practice again. There are 4 questions here for you. You may pause the video to answer these 4 questions. Do not look at the answers provided in the next slide until you have finished all these 4 questions. Thank you for watching this video.